Kindly message them and tell them. Okay, I think we have already waited. Cannot wait for more time. So we'll start off with the experiment. Okay, our first experiment, okay, of the DSP lab is, okay, truth table and logic gates. Truth table and logic gates. So you can just write down truth table and logic gates. So now, as I told you, okay, I'll just present my screen. Looking at my face, you will not get anything, so I'll present my entire screen. Okay. Please let me know if you all can see it.
Yes, sir, we can see.
Cool. All right. Now, as I told you, okay, our first experiment is truth table and logic gates. Okay. So whenever you want to deal with truth table and logic gates, what it is, AND gate, OR gate. So our experiment is basically to prove or to verify your AND gate, OR gate, NOT gate, XOR gate, okay, NAND, NOR. So all these gates to verify. So whenever you want to check it out, okay, what you got to do is don't go directly to the VLabs. Go in Google search. You can see my screen, now. So go in Google search, okay, and just type logic gates. Okay, put a dash and write VLabs. So once you put a dash and write VLabs, okay, you will already get. So one is already available. Okay, implementation of logic gates. Okay, you even have verification and interpretation of truth. This is also there. Okay. Now this is PLC. We don't want PLC. We want basically this. Okay. So verification and interpretation of truth table for AND, OR, NOT, NAND, NOR, XOR and XOR gates. So your very first thing, which is here. Okay. So this is your aim, verification and interpretation of truth table. So I experiment truth table and logic gates, okay, will basically help us to show theoretically and practically that the values obtained are the same, and we can verify, okay, the AND gate, OR gate, NOT gate and all these gates which are here. Okay, your aim is here, theory is already here, so you already have your theory, everything written here. You only have to copy and paste it and put it in your Word document as per this. Just what we have discussed last time as well. Okay. Then procedure. Okay. So this is your procedure. Since you're using V Labs, you can write this procedure down. Then comes your simulation. You all can hear me, right? My voice is clear, no?
Yes, sir.
Cool. Okay. So now comes the simulation. Okay. So which gate you want me to try first? AND gate?
And and
Okay. So we'll try the AND gate. Now when you open the AND gate, okay, you will get two simulators. Please, everyone be with your laptops. Okay. You'll get two simulators, simulator 1 and simulator 2. Now in simulator 1, now what gate it is? AND gate. So we know it is a multiplication thing. Okay. So if there are two inputs, okay. So say if there are two inputs A and B. So if both are 0, 0 into 0 will give us 0. 1 into 1 will give us 1. 0 into 1, 0. 1 into 0, 0. So all the values will be 0 only as output. Only for the last input where both the inputs are 1, you will basically get a 1 at the output. So how we can merge this gate? So what we could do is, we are using two NPN transistors here. You can see this NPN transistor, everyone. So we have one NPN transistor here, Q1, and we have another NPN transistor, Q2. Okay. Now what is happening is, whenever there is a base signal given here, okay, this collector and emitter become short. That means this line, whatever voltage or current is here, will pass through this, will go into this. If there is no voltage given here, it will be basically in off state. This will not turn on. Okay. Same thing for this. Okay. Now let's see how we basically connect. So first we'll connect the battery. So I'll just double click and get the battery connected. So now the battery is connected. This is my main switch. Okay. So I'm turning it on. Okay. Now you can see the green. It has become from red to green, everyone. You can see this, guys. Hello.
Yes, sir.
So green,
Yes,
that
sir.
means current is basically flowing in this. Now say we will check out for the various conditions, A and B. This is my input, A input and B input. Okay. So for 0 and 0, right now it is 0, right? For 0 and 0, is the bulb glowing? No, right?
No,
So
no, sir.
my value is 0. You can see this, the current enters into this, goes to this resistor, and finally goes to the battery. So my this thing is 0. Now I will take for the condition 0, 1. So I'll put 1 here. Is my bulb glowing? No. So the condition is again 0. It is acting like my normal AND gate. Then I will keep 1, 0. Is the bulb glowing? No. So again it is 0. So even for 1 and 0 it becomes 0. And now I'll try for 1 and 1. Bulb glue? Yes. Everyone understood how this is? Very simple simulator. Not some rocket science. Okay. Then the second one is simulator 2. This is all what we have done in the practical, in the theoretical class as well. So say A is 0, B is also 0. So when both are 0, what we should get? This is for the verification of the truth table. If both are 0, what we should get at the output?
0.
Very good. So press check. Okay. And when you press check, it will tell you. Okay. 0, 0 gives us 0. So the answer is correct. So this is a checker. For example, now let's see. Okay. If I put here 1, if I'm saying I'm getting the output as 1 and I press as check, it will come incorrect. So that will tell me that there is something wrong. Everyone clear with this? Guys?
Yes, sir.
Okay. Now try the OR gate. For OR gate, what should be our response? For 0, 0 should be 0. 0 plus 1 gives 1. 1 plus 0 gives 1. 1 plus 1 gives 1. So the output will be what? 0, 1, 1, 1. So now let's see if this is working for this as well. Okay, so here we can just use two diodes, which makes it very simple. No need of BJTs and all. Just two diodes. Okay, so first we'll connect the battery. Okay, battery is connected. Okay, now say I press switch 1 on. You can see the bulb is glowing. Okay, so for 1 and 0. For 0, 0, it is 0 only. Okay. Now I'll check for 0 and 1. Yes, the bulb glows. Then for 1 and 1, also bulb glows. And how I did this, I go into my simulator 2 as well and check out. So 0 and 1 should give us what? 1. So I'll see whether this is correct or not for an OR gate. So my answer is correct. Everyone came to know how to do this, guys? Hello?
Yes, sir.
Everyone came to know how to do this. It is so easy and so simple. I don't know what more to say. Okay, but just do it, guys. As of now, all of you all. Once you'll finish it, let me know. Now do for NOT gate, NAND gate, NOR gate, XOR and XNOR. It's
So
not easy. Huh?
So I joined late to this lecture. Just tell me, guide me, like how, where to go, which website.
Okay. Next time join on time. Huh? Now, what you got to do is, see, whenever you have, now say our experiment is dealing with what? Truth table and logic gates. Okay. So what you do, go on Google search, just type logic gates.
Okay.
Okay. You got here, click and you click on this, verification and interpretation of truth table. You will get this opened up.
Yes.
Okay. So we basically have to verify your AND gate, OR gate, NOT gate, NAND, XOR and XNOR gates. Everyone clear with this? Okay. Your theory is here. Okay, so it will tell you about all your various gates with the truth table. So now we know the theoretical truth table, but we have to verify it practically. So we'll go to the simulation since we are not attending the practical, we're doing it online. So IIT Mumbai has already kept us a simulation here. So just click on AND gate and you'll get simulator 1 and simulator 2. So now you know what an AND gate is, right? 0 into 0 gives us, Tausif? 0 into 0 gives us 0. 0 into 1?
And is addition, right?
Yeah, AND is what? Addition? OR is addition.
Or
AND is what?
multiplication.
Multiplication. Huh? Diplomat ho na?
Yes,
Huh.
sir.
Huh.
I fuck.
Okay. Huh. Man rakna, because even I am diplomat.
Yeah,
Okay.
sir.
So AND gate is what? Multiplication. So 0 into 1 will give us 0. 1 into 0 will give us 0. But 1 into 1 gives us what?
1.
So all the outputs are 0, 0, 0 and the last one where both the inputs are 1, it gives us 1. So the outputs are 0, 0, 0 and 1. So now let's see if this condition is holding true. What we have here, transistor. Here also we have a transistor, normal transistor switching, NPN, BJT. Huh? So when a base signal is given here, what happens? These two become short. Otherwise, if base signal is not there, it is basically open. So it is a switch. Basically, if you give voltage here, this turns on. If you don't give voltage here, this doesn't turn on. So now let's connect the battery and see if it works as an AND gate. Okay, I turn on the main switch. So right now it's showing current which is here and here. Okay. Now let's see the first condition. 0 and 0. Both my inputs are 0. So if this is 0 volts and this is also 0 volts here, is this Q1 and Q2 turning on? No. So neither Q1 is turning on, neither Q2 is turning on. So is the bulb glowing? No. So for 0 and 0, I get 0 only. Then I'll check for 1 and 0. For 1 and 0, this transistor is turning on. But what about this fellow? Is it turning on? No. So if this is not turning on, is it going to the bulb? No. So for 0, so for 1 and 0, I am getting also 0. Guys, you can hear me?
Yes, sir.
Then, in the same way, 0 and 1. Is the bulb turning on? No. Now if I put both on, the bulb turns on. So for 1 and 1, my bulb it turns on. So I get basically a 1. So now let's implement this in a real AND gate. Okay. So now, for example, say I put, this is a simulator 1 and simulator 2, which you have to do both. So I put 1 and I put 0. So Tausif, you tell me the answer. What should I get?
Zero.
Correct. Okay. So I should get basically 0. So I'll click here, check. So it is basically showing correct. It is so simple. This is like even a third standard kid can do. Okay. Say if I say 1 and if I press check, it shows incorrect. That means my value is wrong. You all got this, everyone? Okay. So like this you do for all the cases. 0, 0. Answer is 0. Check. Okay, then 0, 1. Answer is also 0. Then for 1, 0. Answer is again 0. And then for 1 and 1, the answer is 1. Check. So this is how it will tell you. Everyone clear? So now in the same way, how you did for AND gate, do for OR gate, NOT gate, NAND gate, NOR gate, XOR and XNOR. Once you all finish this, kindly tell me. This is very easy, guys. And keep your this thing right up and all ready. I've already told people what they have to do. Truth table and logic gate, who wants to do? Truth table and logic gate. Hello? Guys? Yatin? You there? Yatin? E1911. Yeah, I know. I'm going to push now for them. So Yatin will basically take truth table and logic gates. Okay. We have Yatin, Harsha, Tausif, Pradeep, Rupam, Shubham. Anybody else pending?
Sir, what I have to do?
Huh?
What I have to do?
I had given the last time
Okay.
allotment tray.
Sir.
You basically have BCD adder. Who is remaining? Shreyash is not given anything, no? Yatin is doing truth table and logic gate, huh? Shreyash, half subtractor and full adder. C. There is Yadav Deepak Ray, 03 roll number. Anyone? Okay, guys, I sent you all the list of experiments for DHD. Okay, and who has to do what? Kindly go through it one time and confirm. I sent it to you all in the group. Sent it to you all in the group. Kindly go and check. All right. Everyone take a screenshot of your NOT gate, NAND gate, what you all are doing, and just send me.
So I'm doing on my system, PC.
Huh?
I'm doing on my system,
I
computer.
can't hear you. Proceed.
So I'm doing on my computer,
Yeah, no problem.
but I cannot send you the screenshot.
Yeah, you can send me a photo.
My camera is like not working. I'll show you.
Okay, but do it. That is important. Huh?
Can you see?
What?
This is front camera.
Ah, cool, cool. Perfect. Until you're doing, I have no problem. Okay, no issues. Go ahead. Okay, now, in the same way, do for NOT, NAND, and all the other bits. Okay, guys, you can do this also. One more thing, I will just continue with that lecture. Hello, everyone. Guys, I'll just continue with that lecture. You all understood this, no? Any problems in this experiment? Very easy experiment.
No, sir, no problem.
Okay, okay, okay. So I'll continue with that lecture. Okay. Harsha, what happened? No, sir, what happened? Okay. All right. So I'm putting the lecture in, okay, because we can will not waste time and we can do some fruitful work. This you all already know how to conduct. Okay, I already showed you. So I'll just from tab.
Of this is proof. If we shift, if we take a decimal, become 4.9, which is equal to 4.9 of the previous one. So no matter which points you take, you will get the same answer. Let's have another check. Just to be sure. And now instead of taking wire points C, D, D, E, and E, F, I will take wire points C, D, B, G, and G, F. So this also should give me the same answer. If this technique proves right, so I should get the same answer. So let's check whether the same answer is achievable. From C to B, from B to G, and then from G to F. So now I'm starting from C and ending to F via point C, D, B, G, and G, F. So I'm starting from C and going to F. So the first terminal it touches is a positive terminal of the voltage source. Positive into positive, positive. What is the voltage source value? 5 volts. Then for the resistor 4 ohms, first terminal of the resistor is negative. So negative into positive, negative. Current is what? I2, that is 1.82 into 4. Then again, the first terminal of the 3 ohms is positive. Positive into positive, positive. What is the value of current flowing in this resistor? 0.74. So 0.74 into 3. Then after this, the first terminal of the voltage source is positive. Positive into positive, positive. So plus 5. Then any voltage source or current source? No. So after that it moves directly to F. So what is the value of this? So we get the value as 4.94 volts, which is again equivalent to the values what you obtained. So this proves that no matter which loop we take, either we can take the CF loop directly, or you can take the CDEF loop, or you can take this loop, or even if you take this, you will get the same value of voltage. So even if you take C to B, B to A, A to H, H to G, and G to F, also you will get the same value, that is equals to 4.9 volts roughly. So you will get 4.9 volts no matter which loop you take. So this proves that any loop is possible, but what has to be considered is the shortest way. So obviously, if I want to complete the problem in a given amount of time, I can take my shortest route, which is C to F, or C, B, B to E, E to F. Because I have only one resistor and a voltage source. In the same way, I have only one resistor and a voltage source here. Whereas the others, I have more than two. So the shortest would be basically these two loops. So the more shorter it is, the more faster you can solve it. VCF via point C, B, G and F will be 4.94. Via point C, D, E, F is 4.88, which is nearly equal to 4.9 volts. And via points C to F is also 4.92 volts. So basically, no matter which loop we take, either if we go for CF, or we go C to D, D to E and E to F, or we go for this loop, or we go for this loop, you will get the same value of voltage. So no matter which or which wire points we take, the value of the voltage will always remain the same. So with this technique, what we have developed, we can say that no matter which points we take, the final outcome will be the same voltage. You can even take across C to B, B to A, A to H, H to G and G to F. Still you will get 4.9 volts only. So you can just try it out with this loop as well. So no matter you take this loop, you take this loop, or you take this loop, you will get the same answer. But obviously, I would always select the shortest loop. So either this one or this one, because it only involves two components. So I can find out my answer more quickly as compared to this. Because this loop contains more than two components. It has two resistors and two voltage sources. So my length and time for completing the problem also becomes more, because I have more values to cater to. So obviously I will take the shortest wire directions or wire points, which is directly either C to F or C to D, E to E, E to F, because I have only two components. So I'll take the shortest route. But this is basically for you to understand that no matter which wire point you take or which loop you take, either this or this, you will get the same answer, because it's just the voltage across those 2 points, and voltage across any 2 points is the same. Now, since we got the value of VCF, I'll rub these steps, since we already proved the point. And now I will go to find out the voltage across VAG. VCF is already found out. Now the voltage across VAG. As I told you, the first terminal is connected to the positive of the multimeter, that's why it's positive, and the second terminal is negative. So the first terminal is connected to the positive of the multimeter, that is A, and the second terminal is connected to the negative terminal of the multimeter. Now I can go via points. I can go via points, which is the most shortest route, via points A to H and H to G. So via points A to H and H to G. And I'm assuming my way is from A to G. So A is my start point and G is my end point or my stop point. Moving from A and going to G. Now when I'm moving from A to H and H to G, what is coming in the way? My 20 volts supply. So A is positive, so I'm moving from A. The first terminal it touches is the positive terminal of the V1 voltage source. So again, positive into positive, positive. What is the voltage supply? 20 volts. After that, any resistor voltage is there? No. So it directly ended. So what is my final answer? Plus 20 volts. But as I told you, it is not necessary that you will only get the answer across these points. You can even get the answer across this loop. You can even get the answer across this loop, or you can get the answer across this loop. So no matter which loop you take, you will get the same answer. So we just try with a different loop and see whether we are going to get the same 20 volts. Now the reason why I have taken this easy one is because we are confirmed that the voltage here cannot exceed below 20 volts. So the value of no matter which loop we take should yield us a consistent value of 20 volts. So now I will try other points and I will see whether it gives me 20 volts or not. So if it doesn't give me 20 volts, that means I know the technique what we are using is wrong. But if it gives me 20 volts, that means the technique what we are using holds good and is correct. So now I will try to find out the voltage across VAG across points. So we go via points. A to B and B to G. Now, as I told you, if you want to find out the voltage across any 2 points, you can either take this loop, you can take this loop, you can take this loop, or you can take this loop. Only what you have to remember is you have to start from one point and end to the other point. And highlight your positive and negative terminals of your multimeter. So now we will take the loop from A to B and B to G. So it is moving from A, going to B and going to G. So this is my second loop. Now even in the second loop, I should yield the same result of 20 volts. So let's see if we are getting the same 20 volts result. Now again, positive terminal of the multimeter is connected to A, negative terminal of the multimeter is connected to G. Again it moves from A A to G. So A is positive. First terminal it comes in contact is positive. Positive, positive. What is the voltage in this? It will be I1 into 5. I1 is 2.56 into 5. Then we have, once it moves here, again the first terminal it comes in contact with is a positive. Positive to positive, positive. Which is 0.74 into then again the other terminal it comes in contact with after the 3 ohm resistor is the positive terminal, first positive terminal of V2. So again positive into positive, positive, which is 5. So this is equal to 20.02 volts, which is nearly equal to 20 volts. So this 20 volts is matching with this. So again, I'm confirmed of this technique consistency. So the consistency of this technique is again proved. Now, how I took points A to B, B to G, I'll even try taking points A to B, B to C, C to F, and F to G. So now I will take another loop and again check for the consistency of this technique. So now I take via points A to B, B to C, C to F, and F to G. So even if I take via these points, I should yield the same result. Again, positive terminal of the multimeter is connected to the first terminal A, and the negative terminal is connected to the second terminal G. And I'm moving from positive to negative. That means I'm moving from A to G. As I told you, you can even move from negative to positive. It makes no difference. You will get the same answer. Only that you have to take care of the polarities. So moving from A to G. As I told you, first terminal of the 5 ohm resistor is the positive terminal. Multiply both the polarities. So positive into positive is positive, which will give me 2.56, which is the current flowing in the 5 ohm resistor into the resistance value, which will give me the voltage. Then I have another terminal which is from in B to C, which is positive in nature. So positive into positive is positive. So it will give me I2 into 4. So 1.82 into 4. And I have, after completing this, it goes to the negative terminal, which is my first terminal of V4. So positive into negative gives me negative, which is 5. Now, from C to F. Now it is moving from C. So the first terminal the current touches, it is a positive terminal here. So positive into positive gives me positive. The current is how much? 4.96 into 2. So I have 4.96 into 2. So I have 4.96 into 2. So after my 2 ohms resistor, I have my 5 volts. Now the first terminal of the 5 volts is negative. Positive into negative gives me negative. So minus 5. Plus into minus gives me negative. Positive into negative, negative. So this will give me a value of exactly 20 volts. So if you check this, you're getting basically 20 volts. So I'm getting 20 volts across VAG via points A, B, C, F and G. So no matter which wire points you take, your answer will always be consistent. You will get the same answer no matter which point you take. So in the same way, how I found out for this loop, which is equals to 20 volts, I can even find out from wire points A to B, B to C, C to D, D to E, E to F and F to G. So even if you do via these points, you will yield the same result, that is 20 volts. So in this way, I can find out the value of voltage across any 2 points. So no matter if it is points VAG, I can take either this loop, I can take either this loop, I can take either this loop, or I can take either this loop. I will yield the same result, that is 20 volts. Now we have found out the voltage across VCF, VAG. Now we will find out the voltage across VB. So I will drop this. This is the shortest way. These steps I have done just to prove you the consistency of the technique that I just told you. Kindly note that this technique is not given in any book. I have developed it myself. Now, we have to find out the voltage across VB. Again, the first terminal of your multimeter is connected to the positive and the second terminal is connected to the negative. And I am moving from D to E. So, D to E. Now, my shortest route would definitely be this. And my other routes would be this, or this. But no matter which route I take, I will yield the same result. So first we'll start with the shortest route. So wire points D2 E. So wire points D2 E. Now the first terminal, as I told you, is the positive and the second is the negative. So if I'm considering my first terminal, I'm moving from D to E. So the first terminal it touches is the 30 volts voltage supply, that is V5. The first terminal is a positive. Again, multiply both the terminals, the first with the first. So positive into positive, positive. So plus 30 volts. Any other resistor voltage source? No. So VDE is equals to 30 volts. Now again I will check the consistency of this technique. Now I have taken across directly points D and E. Now I will take wire points who I will take basically this loop. So I will take wire points D to C, C to F, and F to E. starting from D. The first is a positive terminal of my 8 ohm resistor. So positive into positive, positive. What is the value of current? 3.14 into 8. Then again, the first terminal of this resistor is what? Positive. Positive into positive, positive. What is the current flowing in this resistor? 4.96. So 4.96 into 2. Then, what is the first terminal of this voltage source? Negative. Again, negative into positive, negative. What is the value? 5. So I get a value of 30.04 volts. So I get 30.04 volts. So this is across D to C, C to F, and F to E. So no matter if you take it across this, or across this, I will get the same value. Now we'll just again check the consistency, and it will be a practice for us. We take wire points D to C, C to B, B to G, G to F, and F to E. So basically it is this loop. So I am taking the long loop. So it is D to C, C to B, B to G, G to F, and F to E, and F to E. So now my VDE will be equal to, obviously, positive terminal is connected to D of the multimeter and the negative terminal is connected to E. So taking this long loop, first terminal that it comes across with is your 8 ohms. The first terminal of your 8 ohms is positive. So positive into positive, positive. What is the current? 3.14 into 8. Then, what is the first terminal of V4? Positive. Again, multiply both the terminals. Positive into positive, positive. Then again, first terminal of the 4 ohms resistor is negative. Again, multiply both the terminals. So positive into negative is negative. So negative. What is the current? 1.82 into 4. So I have 1.82 into 4. Then, what is the first terminal of this 3 ohm resistor? Positive. Since I'm coming from this side. So this is positive. Positive into positive, positive. So 0.74 into 3. 0.74 into 3. Then again, the first terminal is what? Positive. Positive into positive, positive. So plus 5 volts. So my final value, what I get, is equals to 30.04 volts. Again, the 30.04 volts is matching with this, and it is matching with So in this way, no matter which loop you take, you will get the same result. Even if you take now for loop B, C, B, B, A, H, H, G, G, F, and F, E, also you will get the same value, that is 30.04 volts. Now this is basically taking your start point from B and moving to E. As I told you, you can even move from E to D. So I'll just give one quick review on how you can move from D to E. Now this is basically if you're moving from D to E. But as I told you, you can even move from E to D. But the sign conventions will not change. So if I have D and E, so this is my start and this is my stop. Now I'll start from E and go to D. Now if I'm starting from E, the first terminal it comes in contact with, see if I'm starting from here, this is taken as my first terminal because it's moving from E and going to D. It's moving from E and going to D. So the first terminal it comes in contact is the V2. But V2 first terminal right now becomes what? Minus. So minus into minus plus. So I get plus 5. Then I have the 3 ohms resistor. The first terminal of the 3 ohms resistor is negative. Negative into negative, positive. So positive. 0.74 into 3. Then again, the first terminal it comes in contact with is positive. So positive into negative is negative. So I get the negative sign, which is 4 into 1.82. So 1.82 into 4 will give me the voltage drop. Then for V4, the first terminal it comes in contact with is negative. So negative into negative, again multiply both the terminals. But here remember, for D it was positive. Here you have to multiply the negative. So negative into negative, positive. So plus 5. Then after this it moves to the 8 ohms resistor. First terminal of the 8 ohms resistor is negative in nature. So negative into negative, positive. So 3.14 into 8, which will again the same result, that is 30.04. Now one more thing you have to remember is, if your VAG is equals to 20 volts, then my VGA will be equal to minus 20. In the same way, if my VDE is equals to 30 volts, then my VEB will be equal to minus 30 volts. Now how does this come into play? Now if I consider my multimeter or my voltmeter and I connect my positive terminal here and my negative terminal here, obviously this is positive and this is negative. So I'll get plus 30 volts. But if I interchange my terminals and connect my positive here and negative here, then what will happen? On my multimeter display or on my voltmeter, I will get minus 30 volts. So I'll get minus 30 volts because this is my positive terminal and this is my negative terminal of my multimeter. Initially this was my positive and this is my negative, which was plus 30. But if I change it, it will become minus 30 because of the polarity which is here. So I'll get minus 30 volts. So in other words, if I'm changing my polarity, even the change of terminals will create the same effect. So if my VDE equals to 30 volts, so obviously my VED will be equal to minus 30 volts. Why it will be equal to minus 30 volts? Because right now I am considering E as positive, D as negative. Because I am connecting the positive terminal to E and the negative terminal to B. So if this is positive here, positive into negative is negative. So that's why minus 30 volts. So always remember, if your VAG equals to 20 volts, so your VGA will be equal to minus 20 volts. So if you change your terminals, your voltage polarities also will change. It is the same thing as stating your G terminal as positive and A as negative. So if you take GA, so I have my G here and I have my A here. So if I'm taking the first terminal as G, that means my positive terminal of my multimeter is connected here. This is my positive terminal and my negative terminal is connected here. But the first terminal here is negative. So if I'm moving from G to A, this is positive right now. Positive into negative, negative. So I get minus 20 volts displayed on the terminal of the multimeter. So that's why it comes minus 20 volts. Always remember and keep this in mind. Always refer to the multimeter side of the well. So now I'll just run this long method. So I can easily find out the voltages through any points from this. Now I know the value of VD is 30 volts, which I directly across points E and E, which is 30 volts. Now say I want to find out the voltage across VED. Now if I want to find out the voltage across points VED, as I told you, the shortest path would be this. So via points to now use this technique. I told you the first terminal of the multimeter, or your positive terminal of your multimeter is connected to E, and your negative terminal of your multimeter is connected to D. So it will be negative. So applying the same logic here, E will be positive right now and D will be negative. So if I'm starting from E and going to C, so the first terminal it touches is the negative terminal of V5. So this is negative. So positive into negative, negative. So I get minus 30 volts. So if you see this, if my VD VEE is plus 30 volts, then obviously my VET will be minus 30 volts. It will have the same magnitude, but its directions will be reversed. So, if this is positive, this will be negative. If this is negative, this will be. So, only difference is that its polarity will be reversed. So, this is what happens. So, in the same way, I have VAG. If my VAG equals to plus 20 volts, then obviously my VGA will be minus 20 volts. This revolves under a simple concept that if I'm considering my point VDD, so positive terminal of the multimeter is here and my negative terminal of my multimeter is here. So if I'm having my multimeter, say this is my positive terminal and this is my negative terminal. So if I connect my multimeter across points VDD, the first terminal of the multimeter will go on this point, that is my D point, and the second terminal, that is my negative terminal, will go across my E point. So if I am connecting my multimeter across this, in my display I will get it as plus 30 volts, because this is plus and this is negative, so I am getting plus 30 volts. But if I am reversing the terminals of my multimeter, that means right now if the positive is connected to E and the negative is connected to D, since this is positively charged and this is negatively charged, I will get a value of minus 30 volts. So if I am interchanging my multimeter terminals, I will get minus 30 volts. So this is the same thing what is done here. I interchange the terminals. So I want to find out the voltage across VED. So the positive of my multimeter is here and the negative is here. But since this is negative in nature, which is near my positive, it will give me minus 30 volts. So, if you find out the value of VD is 30 volts, then obviously VED will give you minus 30 volts. If you find out the value of VAG, which is 20 volts, so definitely VGA will give you minus 20 volts. If you find out the value of VCF, which is 4.92 volts, which was our first voltage that we have to find out across terminals C and F, we got 4.92. So that means VFC is minus 4.92. So when you are interchanging the terminals, the magnitudes will remain same, only the polarities will change. So your positive will become negative and negative will become positive. So in the same way, how we got VED equals to plus 30 volts, VED equals to minus 30 volts. If VAG equals to 20 volts, then VGA will be equal to minus 20 volts. And in the same way, how we got VCF equals to 4.92 volts, my VFC will be equal to minus 4.92 volts. So what we have to remember here is the magnitudes remain the same, it's only that the polarities get reversed. So with this, we basically learn how to find out the voltage across any 2 points in a given circuit. Now say for example, if I want to find the voltage across this resistor, if I want to find out the voltage across this resistor, it will be what? V equals to I into R. But I can even find the voltage across this, which will give me the same. The voltage across this will give me the same, and the voltage across this, which will also give me the same. So it is across these 2 points. This will give me the same voltage, but this will give me the same voltage. So with this, we can find out the voltage across any two points in a given. Well, my name is Professor Ravi Pereira, and I'm from RIT Engineering College. And today we will learn how to voltage across any two points in a circuit. So, say if I want to find the voltage across VC across these 2 points, or if I want to find out the voltage across AG. So if I want to find out the voltage across these 2 points and these 2 points, what are the steps required to be followed? So in this system, we will first have to understand the fact that if you're having a multimeter, say you want to find out the voltage across VC, say you're having a multimeter. Now your multimeter basically has terminals. It has the positive terminal and it has the negative terminal. So if basically or practically using my multimeter, and if I want to find out the voltage across VC, I will take the positive terminal of my multimeter and connect it here, and I'll take the negative terminal of my multimeter and connect it here, and I the voltage to my rating. So the positive and negative terminal of my multimeter will be connected here. In the same way, we are even going to solve this problem. Now, if you see the given circuit, you have 4 points in the circuit: A, B, C, and D. And you have another circuit named as E, F, G, and H. However, the only twist in the circuit is that there is a voltage source of 10 volts, which is separating these circuits. Now, how this voltage source is separating these two circuits? If you connect a voltage source between these 2 points, as you can see, there is no continuity for the current. Because even if this voltage source is there, the current doesn't get a continuity, because current has to go and return back to the same negative terminal. So there is no continuity. So if there is no continuity for this V2 volts for the current to flow, I can basically isolate this circuit and I can isolate this circuit. So this circuit will be totally independent and this circuit also will be totally independent. But however, if there was a short between C and H, then there will be a continuity. Then obviously there will be a loop. But since there is no loops here, I can take this whole circuit independently and this whole circuit independently. So now I will first take so these are your problems. You have to find out the voltage across C and D, AG. So I will just mark this C, E, and B, AG. So since the voltage source is isolated, I'll take the first one. I'll draw the circuit again. So I have 6 ohms. I have 5 ohms, and I have 9 ohms. My 6 ohms is considered as R. My 5 ohms is considered as R2, and my 9 ohms is considered as I. I'll take this as R1, R2, and R. And obviously with A, B, C, and D, which are my points. Alright, now I got R1, R2, and R3. I have the voltage V1, which is equals to 20 volts. So now I have this in the circuit. Now when I have this circuit, I can basically find out the current flowing in this circuit. I can find out the current flowing in this circuit. So say I name the current as I1. I name the current as I1, which is nothing but I1 in clockwise direction, because your voltage source, in your voltage source, you have your positive terminal and your negative terminal. So current flows from positive to negative. So obviously my current will be in a clockwise direction. Now what I have to find here is the current I1. Now what information do we already have? We have the value of R1, R2, R3. So I'll total up all these resistances and name it as R1, which is equals to R1 plus R2 plus R3. So it will be 6 plus 5 plus 9, which is equals to 20 ohms. So I got the total resistance. I already have the voltage source. Now from Ohm's law, we have V equals to I into R. So I equals to I1 will be equals to V divided by R. So it will be V1 divided by RT1. So we have 20 divided by 20 ohms. 1 amp. So now current, which is equals to 1 amp. So 1 amp of current is flowing in this whole circuit. So if current is flowing in this circuit, I got my value of current. Now I have to assign my directions. Now always remember one thing, okay? Your voltage directions will never change. So you have your positive and negative. Now your current is flowing from positive to negative. So when your current flows, the first terminal, say this is your resistor, it has 2 terminals, one terminal here, one terminal here. Same way, it has one terminal here, one terminal here for R1. And for, sorry, this is R3. And for R3 it will have one terminal here and one terminal here. So the first terminal, it basically touches, becomes positive. So the first terminal your current touches of any resistor becomes positive. The second terminal becomes negative. So now the current moves here. First terminal it touches becomes positive. Second terminal negative. Again, first terminal positive. Second terminal negative. I will highlight this with the color. And the purpose behind this highlight is also crucial to the step. Basically, how to find out VCE or VAG. So this is the first part. Now, how we found out the ABCD circuit? We will even find out the EF. I have taken this again. These two circuits independently because V2 acts as an isolator between these two circuits. Thereby, this circuit can act independently and this circuit can act independently because there is no permitting for V2. If this was short, then there would be a current would go and return. But since there is no current going and returning back to V2, I can isolate these two circuits. So now going forward, circuit EFGH. So EFGH circuit. So I put my points E, F, G, and H. So this is my R5, this is my R6, and this is my R4. R4 equals to 8 ohms, this is here, 5 ohms, and 7 ohms. And I have my P3 equals to 40 volts. Okay, so I have my second. Now, as I told you, you have to consider all these circuits independent. So I have my second independent circuit, which is EFGH. So for your voltage sources, the polarities will have changed. So this will be positive, this will be negative. Current flows from in a voltage from positive to negative. So there is a go and return point. So if it flows from positive to negative, my direction of current will be in the anti-clockwise direction. So my current will be in an anti-clockwise direction. So I will name this current as say I2. I'll name this current as I2. I didn't name this as I2 because in my 10 volts voltage source there is no I2 current. So here my I2, if there is a current, my I2 will be equal to 0 because there is no go and return path for my current. So to highlight that, I have kept this as. So now you have your. So if my current is flowing from positive to negative, I can even denote my signs. So this will be positive, this will be negative. First terminal touches becomes positive, second terminal touches becomes negative. Positive, negative, positive, negative. RT2, which is equals to R4 plus R5 plus R6, which is equals to 8 plus 5 plus 7, which will give me total resistance of 20 ohms. So now I have my RT. After getting my RT2, I'll find my I3. According to Ohm's law, we have V equals to I into R. So I will be equals to R. So I3 will be equal to V3 divided by RT2. So V3 equals to 40 ohms divided by 20, which is equals to 2 amps. So for my ABCD circuit, I got my I1, which is equals to 1 amp, and for my EFGH circuit, I got my I3, which is equals to 2 amps. If you notice, the currents are positive. I have 1 amp also in positive, I have 2 amps also in positive. So whatever direction I have assumed here and here is basically correct. Now this is basically using a simple funda known as Ohm's law. But you could even go for KVL and also solve this circuit. If we solve it through KVL from the shortcut method, which I have already explained later, it would be voltage sources on one side and drops on the other side. So it would be 20 volts. There is no other voltage source. There is only one voltage source in this circuit. So 20 volts equals to I1, which is flowing in 6 ohms, 5 ohms, and even 9 ohms. So 6 plus 5 plus 9 is 20. So 20 equals to 20 I1, wherein I1 equals to 1. So I can even find out using KVL method or mesh analysis. Again, you can even find out using KVL, mesh or loop analysis for this circuit. So it will be what? 40 equals to 8 plus 5 plus 7, which is 20 ohms. So I2 is flowing in 8 ohms, 5 ohms and 7 ohms. There is no other I1 or I2 current which is interfering with this. So it will be 40 volts equals to 20 I3, wherein you will get I3 equals to 2 amps. So you can even solve these two circuits using a normal principle such as KVL, loop current or mesh analysis. So we can even solve using that. It's whichever method you will get the same answer. Only remember one fact: if the answers come in minors, that means whatever direction you have assumed is wrong and the directions have to be changed. So now coming back, we already got 2 amps and 1 amp. Now putting all these values in our main circuit diagram. So we have for the ABCD circuit I1. So I'll substitute the value of I1 here. Okay, wherein I1 equals to 1 amp. So I wrote the value 1 amp. I have to even input my directions. Voltage source direction will never change. This will always be positive, this will always be negative. However, resistance will depend upon the current. So I have positive and I have negative. Again here, positive, negative. So put the direction for this. Then again, positive, negative. Now, in the same way, I have to put these values as Now here I3 is in the anti-clockwise direction. I3 value equals to how much? 2 amps. Okay. Again, my signs, positive, negative. Again here, positive, negative. Again here, positive, negative, positive, negative. So I inputted all the values. Now after this step, you basically have to find out the voltage across VC. Now what will be the voltage across VC? Now always remember one thing. As I told you, finding out voltage between 2 points is basically like connecting 2 multimeter terminals across those respective points. So if I'm saying it is VC, I want to find out the voltage across VC, then it is basically taking your positive terminal of your multimeter, connecting across C point first, and your negative terminal connected across E point. So you have your positive and negative terminal. Same way for AG. Since A is first, the positive terminal will be connected at A and the negative terminal will be connected at. So if you say VC positive here, negative here. So your positive terminal of your multimeter will be here and your negative terminal will be here. So I took this terminal as positive, which I am denoting with the circle, and I took this terminal as negative. So I have my positive terminal and I have my negative terminal. Now for this problem, you can go either in 2 ways. You can either start from negative and go to positive, or you can start from positive and go to negative. So we will start with the first method, that is going from negative and then reaching to positive. So we start from negative and go to positive. So from our problem, when you are seeing this, okay, if you are trying to find out the voltage between VCE, as I told you, your start point will always be from negative to positive or positive to negative. So you can either go in this fashion, you can just see where my finger is pointing, from E to H, from H to B, and from B to C. So you can either take this route, you can even take E to F, F to G, G to H, H to B, B to A to D, and D to C. So you can even take the long route, you can take this short route, you can even go in this fashion, you can even go in this fashion. Whichever route you take, your answer will be the same. At the end of the day, you will get the same answer. But obviously, the route from E to H, H to B, and B to C will be the shortest route. But whatever answer you get from this, or from E to F, F to G, G to H, H to B, and B to C, the answer will always be the same. So right now, first thing, in the first step, mark positive, negative, and mark the points wherein you're going to take. So if I'm taking VCE, I'll say wire points E to H. H to B. And finally B to C, which is my shortest distance. which is my shortest distance. Now, when you start, as I told you, your E point is your negative point. So I have to take it from E. So if I'm coming from E, the first component I know this is a resistor. So what is when I'm coming from here, this terminal is basically positively charged. So I have positive. But what is my sign here? Negative. Always multiply both of the operators. So negative into positive will give us what? Negative. Positive will give us negative. Okay. Now you have to use the same KVL logic. So according to KVL, we have which states the number of voltage sources in a loop equals to the number of voltage drops in that particular loop. So if we want to find out the voltage across VC, now C is the positive terminal of the multimeter and E is the negative terminal of the multimeter. So if this is the negative terminal, now I have to find out the voltage across these 2 points with respect to C and E. So if we are starting from the negative terminal, and ending at the positive terminal, so the first components it meets via these points E, negative, B, C. So if it is going here, it will first meet the resistor of 5 ohms. The first terminal of the resistor is positively charged. So whatever operator you have here, you have to multiply it with the negative terminal of the multimeter. So if I have positive here, it will be positive into negative will give us negative. So I got my sign. Then how many ohms it is? 5 ohms. What's the current flowing in it? I. I have to find out the voltage across this, I have to find out the voltage across this, I have to find out the voltage across this. According to Ohm's law, we have V equals to I into R. So it will be 5 ohms into I2. So 5 into 2. So it will be I2 into R5. So I got my first voltage. Now again, it will move from point E to H, which is done. Now it will move from H to B. In between H to B, what we have? V2. Again, the sign conventions are positive and negative. So first terminal it touches is a negative terminal. Negative into negative, positive. So again I put my sign. Now what is the voltage across V2? I don't require the current because voltage is already given, which is 10 volts. So I don't need to use basically Ohm's law because it is the voltage source. So directly I write 10. Now I reach at point B. Now from B to C. Now if I am moving from B to C, the first terminal it touches is a positive terminal of R2. The first terminal it touches is positive. So positive into negative again gives me negative. So it will be R2 into I1 into R2. So substituting the values, we get minus 5 into 2 plus 10 minus 1 into 5, which will give me minus 5 volts. So I am getting minus 5 volts. Now you might have noticed it's minus 5 volts. That means if I connect my multimeter across these 2 points, my positive terminal here and my negative terminal here, I am getting minus 5 volts recorded on my multimeter. But however, if I shift my terminals, that means I get my negative terminal, my black terminal of my multimeter here and my red terminal here, I will get plus 5 volts. So if VCE equals to minus 5 volts, then I can say that VEC equals to 5 volts. I hope this logic is understood. So if I'm taking VCE, it will be equal to 5 volts. That means E will be positive, C will be negative. So my positive terminal will be connected here, negative terminal will be connected here. So VCE will be negative, but if I shift both the terminals, my VEC will be 5 volts, which is a positive. So we found out basically the value of VCE and VEC. Now we basically want to find out the value of VAG. Now there's one more thing I want to tell you here. To find out the value of VCE, I have solved it using the shortest method, the shortest point. That means from E to H, H to B, and B to C. You can even solve using the same method what I've taught you. From E to F, F to G, G to H, H to B, and B to C. You will still get the same value, that is -5 volts. So it will be the same fashion. The first terminal it touches is a negative terminal of this R4 resistor. So negative into negative, positive, R4 into I3. Then here, positive into negative. So -40, negative into negative, positive. So 7 into 2, then again negative into negative, positive. So 10 volts plus 10 volts. And once you come here, it will be positive into negative, which is negative. It will be 5 into I1, which is 1. And your final point. So even with this loop, you will get the same answer. Even with this loop, you will get the same answer. Even with EF, FG, GH, HB, BA, AD, and BC, also you will get -5. So this you can even try at home. Your answer is not going to change. So no matter which terminals they are, C or E or A or G, you can basically go for C and E. Either you can take this loop, you can take this loop, you can go even with this loop, or you can even go with this loop. But your answer will come as -5 volts. So you can go across whichever points, but finally from E you have to reach to C. Now you will solve for points A, G. So I will find out the voltage across V, A, G. So now to find out the voltage across V, A, G. So even to find out the voltage across V, A, G, is the same logic. My positive terminal will be connected across A of the multimeter, and my negative terminal will be connected across G. So I will present the positive terminal of the multimeter here and the negative terminal here. Now once this is established, it's the same logic how you found out for VC. So now we are going to start from G and go to A. So I will just note my points. So via points, so I'm starting from G. So we can go from points G to F, F to E, E to H, H to B, B to A. Or we can go from points G to H, H to B, B to C, C to B, and B to A. But the shortest point available where we can avoid most of the components and solve it in a more quicker manner would be from G to H, H to B, and B to A. So this would be the quickest path such that to solve our problem effectively. So if I have points G, I'll move from G to H, then I'll move from H to B, then I'll move from B B2. So this will be my points. Now once I establish my points, I will write the values using KVL method. So by KVL we have, this is VAG. Always for your sign convention, remember this is negative. So operators will be multiplied. So negative into negative will give me positive. This is how I'll get my sign convention. Now what is the current flowing in R6? I3. So I3 into R6. So I establish my first component. Then second, I get my G2H. So I will move from H to B. So in between that I have my second component, which is V2, which is negative in nature. So negative into negative, positive. V2 value I already know, it is 10 moles. Then negative into negative, from B to A, negative into negative, first terminal is positive, which is I1 into R. So my value will be 2 into 7 plus 10 plus 1 into 6, which will give me 30. So my voltage across VAG, across these 2 points, will be 30 volts. So coming back to this system, what I have followed is, always note your points. First A and G, say it is for VAG. Always A, the positive terminal of the multimeter will be the first terminal, so that's why I took this as positive. And the second terminal of the multimeter will be your negative terminal, which will be connected across G. So I took this as negative. Highlight positive and negative. Now, to get the polarities, simple technique, we have already found out all the polarities. So you will get negative into negative, positive, that's why it's positive here. Again, negative into negative, positive. It will always be the first terminal it touches. So negative into negative, positive. Again, negative into negative, positive. Okay, so this is your first terminal it is going from. So it's going from points G to H, H to B, and B to A. That's how I got 30 volts. Now there is an alternate method as well, where we can basically start from positive and even go to negative. Now the method what I taught you here is basically from negative. The start point is your negative points. If we are seeing from BC, we are going to consider voltage across BC. I have started from the negative and then to the positive. I started from the negative and going across E to H, H to B, B to C. However, the alternate method can also be done. The alternate method states that you can even start from positive and go to the negative terminal. As you see here, BC is across points E to H, H to B, and B to C. So now I can even take wire points C to B, B to H, and H to E, which is the reverse of this. So I'll start off with C, then go to B, then go to H, and then go to B. So let's see whether the alternate method is also possible. So if we see the alternate method across any 2 points C and E, I started off from the negative, so now I start off from the positive. So if I'm starting off from C, the first terminal I get, I have to go across C to B, B to H, and H to E. So I have to go in this fashion. The rule remains the same. The first terminal it touches of that component, you have to multiply with that value. So this is positive here. So positive into negative will give me what? Negative. Therefore I have minus I1 R. Then again, the first terminal it touches, Positive into positive will give me positive. That's why plus 10. Then again, positive into negative will give me negative, which is minus I3 into R5. Wherein I will get the same answer, and then VCE equals to minus 5 volts. So you can either start off from negative, go through the points, and then go to positive, or you can start off from positive and go to negative. Only what you have to remember is the first terminal in such is your first point. So if I'm starting from positive, this is the first terminal of my component. So positive into negative will give me negative. Again, I will show the second component, which is my voltage source. First terminal is positive, so positive into positive is positive. Then again, first terminal of this resistance is negative, so positive into negative will give me negative. So either I can start off from negative, positive into negative, negative, negative into negative, positive, negative into positive, negative. So I can either start off from negative to positive or go from positive to negative. Your answer will be the same. So this is also the alternate method which I basically taught you here. So you can either use any, you can go from positive to negative or negative to positive. So whichever method it is will give you the same answer. Even your wire points, VCE, which I told you, if you're finding out the voltage between B, C, you can even go across E to F, F to G, G to H, H to D, and B to C. Even across this point, you will get the same. Even across E to H, H to D, and B to C, also you will get the same answer, that is minus 5 volts. So this you can try and you can get the same value.
Okay, guys, I know it was a long lecture. Okay. Take your roll call. Okay, Tausif, present.
Present, sir.
Jadav. Jadav is there. Okay, Harsha, present. Pradeep.
Present, sir.
Pradeep is on. One minute, I just increase my volume. Yeah. Rupam. Rupam present. Shreyas.
Present, sir.
Vinci. Shubham is present here. Vinci. Vinci had come no earlier. Yatin present. Okay. All right, guys. Take care. Thank you. Thank you.